This is the second video of this module where we're building the Simio model of a serial manufacturing line. In the first video, we built the base model, and so here was our base model where we have parts that arrive, are turned, drilled, milled, inspected. There's a three-way decision from inspection. The good parts go to pack and then depart, and we created the model, we created the experiment, we verified our experiment with our computational results. We did a queuing analysis to verify our model. In this video, what we'll do is we will go and add some of the other components to the model. And so if we look, start back at the top, we have the arrival rate in the model done, and we have our inspection outcome done. The number one here, the moving in zero simulated time is happening using connectors. So the second thing that we need to do, or the first thing we need to do in this video, is to change the entity symbol. So what the statement says is that we want to change colors after the turning and drilling process. Entities should start with the default green color and then change to red after turning, and then change to blue after finishing. So going back to our model, let's zoom in our model a little bit. We know that what we have to do to change a symbol is to add elements to the symbol list and then tell Simio where to make the change. So if we look at our part entity, we can go to the ribbon, the symbol ribbon, and we need to add two additional symbols because the statement said we start out with green, then we go to red, then we go to blue. So I now have three symbols in my symbol list. I'm going to make the second symbol the active symbol and simply change it to the color red. Then I'll make the third symbol the active symbol, and then we'll change it to the color blue. And so now when we look at our symbol list, we have green, we have red, we have blue, the colors that were stated in the problem. Now, in terms of how to change the symbol, or how to select a new symbol from the symbol list, if we look at the parts entity instance and we look at the animation category of the properties, we can see that the current symbol index right here, we make this bigger so that we can actually see the property name. Current symbol index is defined by model entity dot picture. So if I go to my model entity definition, the state picture is defined by Simio. So it's defined in the model entity when we placed the instance here. So basically all we have to do is update that value when we want to switch to a new symbol. So it starts off with value 0, hence the green symbol. When we want to change to red, we simply need to change that entity state to get a value of 1, and we want to change it to blue, we set the entity state to value 2. So after turning, we wanted to turn red, so I simply go to my state assignments, and before exiting, I simply assign that entity state a value of 1. So the state variable is model entity picture, and we want to assign it a value of 1. And we'll go ahead and do the second one too while we're here. Go to state assignments for the drill. Before exiting, add model entity dot picture. This time a value of 2. So when we now run our model, let's slow it down just a little bit. They should start out green, then change to red, then change to blue. There's the red, there's the green, and there's the blue. So I'm sorry, the red, the blue. Start out green, change to red, change to blue in the model. So just to review, what we had to do in order to change the symbol is update the symbol list to add our additional symbols, and we modified their color. Then we used the current symbol index property, entity picture, and then we assign the value at the location in the model using state assignments. The next thing that we're going to do, get the assignment back, is we've already named the objects. We did that in our initial model build. So we have a status plot that displays two things: the instantaneous number of entities in the system and the average number in system over time. And one more instruction here is the time range for the plot should be 10 hours. So go back to our model, and we're going to grab the status plot. Just make the status plot here, and then set the interval to 10. And let's make the scale a little bigger. Oops, went the wrong way there. Make it 1. There we go. And so we now have the plot defined with our 10-hour time window. The thing we need to do next is to add our two expressions. So we have two different things we want to plot: the instantaneous numbering system and the average numbering system. So I do that by going, we'll just use the repeat editor here. And our first one, let's do the instantaneous numbering system. So we need parts, population, number in system. Number in system. And let's just call this NIS, standing for number in system. And so let's check it. And as we run our model, we should see in the plot the instantaneous numbering system. So at any point in simulated time, it should represent how many entities, or it should show us how many entities we have. And so it looks like it does. We could speed up the model a little bit. Let's go here and make this 25. And we can see the instantaneous numbering system being updated as entities arrive and depart. So the second thing we want to add is the average numbering system. And so the average numbering system uses a very, oops, I added one too many, so let's delete that. Uses a very similar expression. So we have the parts, which is the model entity instance. Then we have the population. So this is saying over the entire population of run spaces of this instance, I want the current numbering system. To do the average, we simply append average to the expression. So this is parts, population, number in system, average. And we'll just call this average NIS. So we get rid of that label, or the long label anyway. And now we have our two values. And so as the model runs, we now see the instantaneous value in addition to the long range, or the average value over the run. One note about these expressions: if we look in the the results section, and we get rid of the filtering that we had earlier. Let's get rid of my filtering here. If we don't know the exact expression, one way to help figure out that expression is to look in the in the results tab. And you can see here that we have our object parts, population, number in system, average. So this is the average value. Of course, what this one is showing is at the end of the replication, the end of the run. And what ours does is it gives it to us up until the point, when it plots. But we can sort of piece together this expression if you have a general idea that parts, population, number in system, average, and then we get, of course, the instantaneous value doesn't use the average. So learning to do semio expressions is something that you have to get used to doing, but there's a very natural structure to them that as the more you do, the more you'll learn that structure. The next component of the model that we'll look at is the user-defined statistic. Number 5 says create a user-defined statistic that records the number of times each good part is milled. Note that since inspection outcome is probabilistic, some parts will be milled multiple times. And so what we want to do is when an entity, or when a part entity comes through the milling process, we want to track that number. So we want to increment the number, and then we want to record that value, but only for the good parts, not the bad parts. So what we need to do is create an entity state so that we can keep track for each individual entity how many times that entity has been milled. So I'm going to go to my model entity and definitions and add an integer, and let's just call this num milled. Num milled, so it will start out at 0, and so when an entity is created, arrives through the source, it's going to have a value of 0. And so we simply need to update that value when it gets through at the mill. So we're going to, before exiting, we'll just increment that value. So we created a value called model entity num milled, and we'll simply increment that value. Model entity num milled plus 1. And so now each time it goes through, we'll increment the value. And when the entity departs, because it gets incremented each time it goes through mill, so if it fails inspection, it gets incremented and fails inspection and so on. When the entities depart, we will have the number of times that that particular entity has been milled. So our metric, or the performance metric that we're trying to track, is the average number of types, or records the number of times that each good part is milled. So in order to do that, we need to create a tally statistic so that we can track those values. So I'm going to go back to my model, definitions, elements, create a tally statistic. And let's just call the tally statistics good parts milled. Good parts milled. And then we go and record those values in the sink where the good parts go. So because we're recording the statistic, the tally statistic, on the input to good, those parts that are rejected won't be counted in our statistics. So when they enter the node, we'll simply record the value into the tally statistic that we just created. So there's our good parts milled, and we need model entity. Let's use the expression editor this time. Model entity num milled. And so each good part that goes into the sink, we will record the value of num milled. Okay, so we can test it. So we go back to our run, and let's just run in interactive mode first. And we should now see a new category for our user-defined statistics. Let's see if we can grab that guy, results, and there we have it. Good parts milled, the average of 1.376. So on average, good parts will be milled 1.36 times, so that accounts for the fact that they can fail inspection multiple times. So as a review for the tally statistic that we just created, there were 4 basic steps. The first thing that we did was we defined a placeholder. We defined a state variable on the entity to count the number of times that each part was milled. So that was step 1, is to create the entity state variable. Then we incremented the value after it went through the milling process, because the particular statistic we want was simply incrementing once each time the part is milled. That's step 2. Step 3 was to create the tally statistic. So we created a tally statistic called good parts milled. And finally, step 4 was to record the individual observations into our tally statistic. So that concludes this video. In the final video in this module, we will be implementing the experiment responses specified in the problem statement.